Right, in this video we're going to talk about enzymes and how they work. Now, enzymes are proteins, and if you recall, when we're talking about proteins, we're interested in the sequence of amino acids. So here I have what's called a polypeptide chain, and polypeptide chain is a chain of amino acids binded together. And the difference between the 20 amino acids are these side chains here. Some might be polar, some might be non-polar, some might be positive, and some might be negative. Now what happens is this polypeptide chain folds up into a three-dimensional shape that we're going to call a protein. So when it's folded up, it becomes a protein. And this protein has a very specific three-dimensional shape. So when we're talking about proteins, we are interested in the sequence of amino acids which determines the three-dimensional shape of the protein. Now, why are we interested in the three-dimensional shape? Well, the three-dimensional shape determines the function. And this is going to be especially relevant when we are talking about enzymes. So if we do something to change the three-dimensional shape of our protein, we are going to have an impact on the function. This might be a change in function, or it might be a loss of function. When we are talking about enzymes, we're going to be talking primarily about a loss of function if we change the shape. So now let's look at why the three-dimensional shape of an enzyme is so important for its function. And actually, if we change the three-dimensional shape of an enzyme in any way, it won't be able to carry out its function at all. So enzymes are catalysts, and what a catalyst does is speeds up a chemical reaction. And there are two chemical reactions that we're going to be interested in when we're talking about enzymes, at least in this video. One is hydrolysis. And what hydrolysis is breaking polymers into monomers. So this might be getting a starch molecule, for example, which is lots of glucose molecules stuck together, and breaking these bonds here so that we've got our individual monomers, which might be glucose, and then our body can use that glucose. Another reaction is dehydration synthesis. And what this does is forms polymers from monomers. So this might be, for example, taking our individual amino acids and bonding them together with peptide bonds into our polypeptide chain, which will then fold up into a protein. So the process of protein synthesis. So these are our two reactions that we're going to look at. So let's draw our enzyme. And we often draw enzymes in simplified ways. And there are several parts of an enzyme. The one that we're interested in here is called the active site. And the active site is where the substrate binds. Now the substrate is our molecule that we're interested in. So let's say we're going to look at dehydration synthesis. Okay, we're going to get some monomers and we're going to bind them together into polymers. So we've got some monomers here. Now we might have lots of different types of molecules floating around. But really, really important, something that we always must remember, is that the monomer that the enzyme is going to bind together into our polymer, so the enzyme that works for the reaction that we're talking about, fits into the active site here, and only that monomer will fit into the active site. So these molecules here and these molecules here, these monomers, will not fit into the active site. And the active site is where the reaction occurs. So what's going to happen is that the molecules, the monomers, are going to enter the active site, and then the enzyme will catalyze this reaction. In this case, we're going to be forming this bond here because we're looking at dehydration synthesis. Now this is called the enzyme substrate complex. So the enzyme substrate complex is the enzyme with the substrate binded inside the active site. So here's the active site here, and the substrate are binded inside. Now what's going to happen is that the products are going to leave the active site, and the product in this case is going to be our two monomers binded together. So now we have the enzyme and we have the products. So this is going to be our polymer, or a dimer in this case, two molecules stuck together. Really, really important to remember is that this enzyme is not used up in the reaction. So this enzyme can go back and more products can bind, more substrates can bind into the active site, and the enzyme can catalyze another reaction. And this can keep going and going and going. So enzymes are not used up in reactions, and that is something really important to keep in mind. The products are used up because these molecules are going to be binded together into a dimer, but the enzymes are not used up.